focus on how to find the domain of a function. We will start with the main concept behind determining a function's domain. Then we will work through various examples, including polynomial functions, rational functions, radical functions, and functions involving fractions with radicals. When working with real numbers, there are two rules we must never break. Firstly, we cannot divide by zero. Division by zero is undefined. Remember this rule when finding the domain of a function with a variable in the denominator. Secondly, we cannot take the square root of a negative number. The square root of a negative number is undefined in the real number system. Remember this rule when finding the domain of a function with a variable under a square root. The domain of a function consists of all possible values of x for which the function is defined. In other words, it is the set of all values of x that you can plug into a function without breaking these rules. Keep this in mind as we proceed. Polynomial functions do not have a variable in the denominator or under a square root. So, we do not need to worry about dividing by zero or taking the square root of a negative number. Therefore, polynomial functions are defined for all values of x, which means their domain is all real numbers. In interval notation, this is written as, in parentheses, negative infinity, comma positive infinity. You can write the domain in either of these ways. They mean the same thing. Now, let's move on to finding the domain of rational functions. Unlike polynomial functions, rational functions do have a variable in the denominator. Therefore, for a rational function to be defined, the denominator must not equal zero, as division by zero is undefined. To find the domain of a rational function, set the denominator not equal to zero and solve the resulting inequality. The solution to the inequality represents the domain of the function. For this function to be defined, x minus 7 must not equal 0. Now, solving this inequality, we find that x cannot equal 7, right? Therefore, the domain of this rational function is all real numbers except 7. To write the domain in interval notation, first represent it on a number line. A number line helps to clearly visualize which numbers are included and excluded from the domain. Mark an open circle at 7. This indicates that 7 is excluded from the domain. Then, shade the line to the left and right of 7. This indicates that all other real numbers are included in the domain. Now, from this, you can easily write the domain in interval notation as negative infinity to 7 union 7 to positive infinity. The parentheses around 7 indicate that 7 is excluded from the domain. Note that parentheses are also used for negative and positive infinity because they do not represent a specific point on a number line. For this function to be defined, x squared minus 16 must not equal 0. Now, to solve this inequality, first factor the quadratic expression using the difference of two squares formula. Then, set each factor not equal to 0. Solving the first inequality, we find that x cannot equal negative 4. Solving the second inequality, we find that x cannot equal 4. Therefore, the domain of this rational function is all real numbers except negative 4 and 4. To represent this on a number line, mark an open circle at both negative 4 and 4. Then, shade the line to the left of negative 4, between negative 4 and 4, and to the right of 4. From this, you can write the domain in interval notation as negative infinity to negative 4 union negative 4 to 4 union 4 to positive infinity. The parentheses around negative 4 and 4 indicate that both of these numbers are excluded from the domain. For this function to be defined, x squared plus 9 must not equal 0. Notice that when we square any real number, the result is always non-negative number. Adding 9 to that squared value will always result in a positive number. It can never be 0, right? So there is no real value of x that would make the denominator equal to 0. Therefore, the domain of this rational function is all real numbers. Now, it's your turn. Please pause the video and give it a try. For this function to be defined, the trinomial must not equal 0, right? Now to solve this inequality, first factor the trinomial. To do that, find two numbers that multiply to give 15 and add up to negative 8. These numbers are negative 3 and negative 5, right? So when we factor, it becomes x minus 3 times x minus 5. Now, setting each factor not equal to 0 and solving for x, we find that x cannot equal 3 or x cannot equal 5. Therefore, the domain of this rational function is all real numbers except 3 and 5. To represent this on a number line, mark an open circle both at 3 and 5. Then, shade the rest of the line. From this, you can write the domain in interval notation. Now, let's move on to finding the domain of radical functions. Radical functions do have a variable under a radical and can have either an odd or an even index. When the index is odd, the expression under the radical can be any real number. This is because taking the odd root of any real number always results in a real number. Therefore, radical functions with an odd index are defined for all values of x, which means their domain is all real numbers. In our examples, the second and fourth functions have odd indexes, so their domain is all real numbers. However, for a radical function with an even index to be defined, the expression under the radical must be greater than or equal to 0. This is because taking the even root of a negative number results in an imaginary number, which does not belong to a real number system. To find the domain of a radical function with an even index, set the expression under the radical greater than or equal to 0, and solve the resulting inequality. The solution to the inequality represents the domain of the function. Remember, if the index of the radical is not shown, it is assumed to be 2, which is an even number and is commonly known as the square root. So, in our examples, the first, third, and last functions have even indexes. Let's find the domain of each function separately. For this function to be defined, x minus 9 must be greater than or equal to 0. Now, solving this inequality, we find that x is greater than or equal to 9, right? Therefore, the domain of this radical function is all real numbers greater than or equal to 9. To represent this on a number line, mark a closed circle at 9. This indicates that 9 is included in the domain. Then shade the line to the right of 9, indicating that all values of x greater than 9 are also included in the domain. From this, you can write the domain in interval notation. The bracket around 9 indicates that 9 is included in the domain. This one is for you. Please pause the video and give it a try. For this function to be defined,